So ideally, the scientific method actually aims to confirm hypotheses through rigorous testing involving ethical, falsifiable, replicable experiments that are designed to avoid biases, including confirmation bias, and contribute to comprehensive scientific theories. And extraordinary gains in our understanding of the world have been the result. Efforts to address, the coronavirus pandemic, through rigorous, replicable, falsifiable, hypotheses and experiments, are moving us closer and closer, towards a vaccine. However, biased humans can conceive and carry out these experiments and have at times, failed rather horrifically regarding ethics, falsifiability, and also replicability as well. So critical thinking is absolutely essential in science. And it doesn't just mean to criticize. It's a set of skills really for overcoming our own biases, which we have to admit and become aware of, including, again, confirmation bias and some of the heuristics that we'll talk about that we apply in certain circumstances that may be probabilistically helpful, but are not necessarily going to be reflective of what's going to occur in a specific experiment. So a couple of these aspects that contribute to effective science include the idea that extraordinary claims require extraordinary evidence, right? Falsifiability, the hypothesis that you're making, it actually has to be capable of being disproved. If it's going to be something that's impossible to test or impossible to set up an experiment to evaluate, we can't say anything about it, right? It's just an opinion then. Occam's razor, which is also called the Principle of Parsimony, which is named after the 14th century British philosopher monk Occam. If two explanations account equally well for something, we should select the simpler or more parsimonious one. And we can talk about some examples of how Occam's razor applies actually, and how maybe in some circumstances it is a more complicated circumstance. Replicability. There's been a huge replication crisis in science, in particular in psychological science and social sciences, that's something that oftentimes experiments can be very expensive to run. They're complex to set up. Oftentimes there are pressures for publication of a counterintuitive result, a surprising result, which then doesn't get replicated until years later. And then oftentimes the follow-up study that doesn't find the same initial kind of arresting novel finding doesn't get as much play in the media. Or oftentimes if you get a null result, if you don't find an effect, that doesn't get published as well. So one of the things that's really a concern often is how scientists may do lots and lots of the same type of study on something, and they don't find an effect, and they don't find an effect, and they don't find an effect, and they just shelve that. They call this the file drawer problem. They stick it in a file drawer, stick it away, and then all of a sudden, by chance, there's something's found, right? But it's in the context of many other studies that found nothing, but people aren't aware of them because they weren't published or promoted. So that's a problem that we have to sort of root out. And we're learning more and more that that scientists need to have a very, very clear description of their methods, the methods that are used in various papers, so that people can actually replicate the experiment using the same sorts of circumstances and conditions, to really see if this is a finding that's sort of persistent and that is scientifically valid. And finally, ruling out rival hypotheses. When we evaluate a psychological claim, we should ask whether we've excluded other possible explanations for it. So you just got to keep an open mind. You think critically, evaluate critically, and really investigate, using a method that has actually brought us a great deal of knowledge about, ourselves and the world.